Good morning, my YouTube viewers. It's Crystal here. I've been up for about the past hour and a half, trying to get this book recommendation system to work so I could do a code review. And after about an hour and a half, I finally was able to get version 10 of version 11 up on Kaggle. I mean, that's just how many problems that I've had. And so it's not really the version that I had ended up with, but I'm afraid to do anything to it because if I do anything to it, I'm afraid that it might not come back. And then so I'm going to go ahead and use version 10, which is not the best version, and give you the code review for it. So this notebook has been made public, so you can look on this notebook, and it's on the Good Books-10K data set, and so you can find it there. So I created this book recommendation system. The first thing that I did was I imported the libraries that I were going to need, and so that was going to be NumPy SNP, which is your numeric computation library, Pandas SPD, which is your data frame library, and then OS, which goes into the operating system to retrieve the files that are used in the program. We imported Matplotlib, which is a graphics library. It plots your data points onto a graph. And we imported Seaborn, which is a higher level graphics library, which also does statistics. So after I imported my libraries, what I did was I loaded my files using OS, and you can see that there's quite a few files in this system to look at. We looked at book underscore tags, ratings, books, sample underscore book, to underscore read, and then tags. So those are the files that are actually in the directory. So we're going to read the files in, and so what I did was I created the data frames book underscore tags equals pd.read underscore csv, and then the link to the data set, and then I created ratings, books, to read, and tags. I removed any duplicates, so you can see that I've removed the duplicates. And then so this is your book tags data frame. It has Goodread underscore book underscore ID, tag underscore ID, and then it has count. So that's how many ratings it got. So it was almost 1 million ratings. So that's why I've had so many problems with this data set, because my computer is not very powerful. If I want to get involved in more intense data science work, I'm going to have to get a more powerful computer, because I've just got a computer that I paid less than £400 for, and so it doesn't do a lot. And yeah, so I can't do a lot of this fancy stuff or memory intensive stuff because I don't have the computing power to do so. Then we have another data frame called ratings, which has book ID, user ID, and rating. And so that was close to 1 million ratings. Okay, so I just wanted to see how many unique values were in this data frame. So book ID was 10,000. User ID was 53,044, and there were 5 ratings. So on the books data set, so we've got 10,000 books, and I set it up so you could display all the columns because I wanted to see what all the columns said. And you have 10,000 books, and 23 columns. So we wanted to look at the info because there were lots of columns, and so most of them were integers and floats, but there were a few objects in there. So this is for the book REC, that's your recommendation system, equals books, book ID, ISBN, title, authors, and original publication here. So this is the new data frame that I have created. So you can see you've got your book ID, your ISBN, your title, your authors, and the original publication year. You've got to read, which we didn't use that in this program. We've got tags, got your tag ID and your tag name. So there were 34,252 unique values in the tag name. So what we did was we created our genres, and there were 36 genres that we created. So you can see all of them here, and then we converted them to lowercase after we created them. So you got 36 genres, and then this is all the genres you've got. So we did something to the tag name. So tag name equals an empty array, tags a tag name equals tags tag names dot string dot lower. So we converted the tag name and tags to lowercase. For tag in tags tag name, tag equals exclamation points dot join brackets filter bracket string dot is alpha tag. So what that means is that just keeps all of the letters in there if they're alpha. If they're not alpha, it just replaces it with a space. Tag name dot append tag, and then so tag name equals tag name. Available tag equals, and this is a filter, tags, and then square brackets, tags tag name dot is in genres, square brackets, then print len available tag. So it just says 71. There are 71 available tags. So this is your tag ID and your tag name, and you only had 71 available tags in all of that after we did that. Join tags dataset to book tags dataset. Books info equals PD merge. Book tags, comma, available tag, comma, how, write on tag ID. This is your book info. So you've got your Goodreads book ID, you've got your tag ID, you've got your count, and you've got your tag name. So, and then you've got 38,510 rows. So I just wanted to see if you had any null characters after I merged the two files, and we don't have any null characters, so that means that I not merged the two files correctly. Now, so we check it, book info again, which is what we've already covered. And so we print book info square brackets tag name dot unique. So these are all of the unique values in the tag name. And I could have done a link to see how many it was, but I didn't. But it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So you've got 28 unique values. And when we did the genre, we had 36 values in the genre. So that means that the genre didn't, not all of the values in the genre carried over into the book info. So we look at your book info, we had 28 values, and we've made a bar chart out of it. So book underscore info, square brackets, tag name, square brackets, dot value counts, brackets, dot plot, brackets, kind equals bar H, brackets. So we created a horizontal bar chart so you can see that the highest, most of the books were fantasy and the least books were cookbooks. So that was interesting. So we're going to remove users if they rated fewer than 10 books. So ratings.group by user ID dot filter lambda x len x is greater than 10. And what I had originally done is I had originally made, well, in the most recent version, I had made it 100 books. But for some reason, this is what was saved, and that is because this program, these recommendation systems are so memory intensive that it didn't save the most recent version, but I don't want to dare do anything to it because I just want to get this code review done, and I don't want to dare do anything to it. So all of the users who had less than 10 book reviews, it went down from almost 1 million to 842,109 rows. Now we're going to plot a distribution of the ratings. So you can see most of the ratings were 4. And then the next one was 5. And the next one was 3. And the next one was 2. And the next one was 1. Plot the number of ratings for each book. So some books had as many as 100 ratings. And then that was, it said, now we're going to say the 10 books with the most rating books, ascending equals true. So the lowest rated books these were your 10 lowest rated books, and these were your 10 highest rating books. So some books had as many as 100 ratings. So we did a value count on that just to check it to see. So now we made a hist plot of ratings per book, and so you can see what that looked like there. Okay, so we checked our top 10 books with the highest rating. So it was The Complete Calvin and Hobbes, Words of Radiance, Mark of the Lion Trilogy, It's a Magical World. Never even heard. You got Harry Potter. And then you've got the 10 most popular books. So the 10 most popular books were Hunger Games, Harry Potter, Twilight Zone, Twilight, To Kill a Mockingbird, The Great Gatsby, and some others. So we're going to merge books REC with ratings. Just want to check something. So we're going to merge books REC with ratings. So ratings with books equals ratings.merge, and then brackets books underscore REC on book ID. So we merge these two files on the book ID. So you've got book ID, user ID, rating, ISBN, title, authors, and the original publication year. And you've got 79,583 rows. So now we're going to create a pivot table. Book pivot equals rating with books dot pivot table. Columns is going to be the user ID. Index is going to be title, and values is going to be rating. So your columns is user ID. So every user ID gets a column. and then the book is going to be your index. And so now what we do is we take that file and we convert it to a sparse matrix. So book underscore sparse equals CSR matrix book pivot. And we're going to select our model. And we're going to use sklearn nearest neighbors. Model equals nearest neighbors. Algorithm equals brute. Model.fit book sparse. So you're going to say it's the nearest neighbors. Algorithm is brute. Distances suggestions equals model.kneighbors. Book pivot.ilot237. So that was row 237 and all of the columns. And values reshape reshape 1, -1. And then what it did was, what I had originally done was I put 500 in there just because I wanted something different and I wanted to see what would come up if I used something different. And then whenever I put 500 in there, then it had completely different book titles, you know. But unfortunately, because this recommendation system takes so much memory, that it didn't save it whenever I chose the 500. And this morning I couldn't even get into edit it. That's just how bad the situation was, that I was going to make a blog post and just say, well, I can't view my own code, which is really basically what has happened. And then so for I in range in len suggestions, print book pivot dot index suggestions I. So these are the suggestions you're going to get. I think it's going to be 5 suggestions. It's going to be 1, 2, 3, 4, 5 suggestions. So the person on row 237 is going to get Harry Potter book set, Harry Potter and the Prisoner of Azkaban, The Lord of the Rings, Harry Potter collection, The Ultimate Hitchhiker's Guide to the Galaxy, and that's a suggestion. But what I had originally done or done yesterday evening or yesterday afternoon was I had set it up for 500, and you got a different selection of recommendations when I set it up for 500. But because I just had such a hard time. I had such a hard time. My computer's not that powerful, so it's just taught me that I need to get a more powerful computer. That I had such a hard time. I could not even get the code up just to view it, much less edit it. And so I thought, okay, well, I'll call up the edit code and I'll do the code review while it's in edit mode. And I couldn't even do that. The computer kept on crashing. So for some reason this came up and I decided to go ahead and do a code review on this. So I'm going to go ahead and conclude my video because I've been talking for almost 20 minutes. And so you can look at my code if you like it and you learn how to do a recommendation system, which are very memory intensive. I'd like to find another data set for a recommendation system that's a small data set and see if I can do it again, because this is the first recommendation system that I've ever made, and obviously I need lots of training on that. So thank you so much for watching my video, watching my code review, even though it's not the code that I would have preferred. And thank you for supporting my channel, all of my subscribers. If you like this video, please like, subscribe, and share. And thank you again for watching my video. I look forward to making more videos, more code reviews for you in the future.